we discuss about abstract classes after we did revision on inheritance. So today our lecture will be on interfaces, polymorphisms, and packages. So let's see if we can go as quick as possible to cover this, even though we started late. So I don't think we still have time to recap on abstract classes, because I discussed this intensively last week. So I think I can just go ahead to talk about interfaces. So when we introduce this concept of abstract classes, we have seen how superclass force the child class to overwrite its own method, probably due to the different way of implementation. When a child class needs to have its own way of doing things. Remember where I think we demonstrated an example with the use of shape and other kind of shapes like triangle, circle, rectangle, which each of them had its own way of calculating the area and perimeter. So having one method in the superclass cannot work across all shapes. That depends on the shape that will determine how to implement such. And that is why we have that method as an abstract class, as an abstract method in the superclass. While the subclasses need to override all the abstract method of the superclass. That's now making the superclass to enforce all the child class to override its own method. So now in the concept of interface, how will the interface different from the abstract classes? So they have some similarities in terms of object cannot be created for the case of an interface, and also in the case of abstract class, we cannot instantiate a class that is abstract or an interface because it's typically an abstract, it's incomplete. When something is incomplete, we cannot have a concrete object to say this object is meant to use for this class because the class is not even complete. So the subclasses that will now complete all the abstract method of the superclass can now be used to create the object. Now, so what is interface? Of course, from the word interface, something that bridges in between the let's say two classes that are not related to some extent. Like say, for instance, in the class hierarchy, we have seen how a student, let me check if we have such kind of example here. Okay, it's okay, it's not here. Now, in the case of where we come to create an object of the superclass of, let's say, students, or let's look at the two classes, student and a lecturer. A student cannot be a lecturer, and a lecturer cannot be a student. What I'm saying here is giving a teaching assignment to students will not make that student to be a lecturer. A lecturer is a group of people. That is a class, let's say lecturer, which comprises a group of people who have kind of similar activities, which a student will not be in that category that can be in a lecturer class. So a student should remain as student, where a lecturer should remain as lecturer. So if they are not related to some extent, what can bridge between them? The fact that we can assign a postgraduate student to teach. So if a postgraduate student can be assigned to teach, then, but still that will not make him to be a lecturer, but can be given a teaching assignment. So in that case, we can call that as instructor, which in this case now, a lecturer is an instructor, a student can also be an instructor. So if you can have something that bridge between them, that is a typical what you mean by an interface. so that they can share the same type. What are we saying the same type here? A lecturer is an instructor, a student is an instructor. Now they share a common type, instructor. So we got to see some of the built-in interfaces that are in Java standard library, and we can also create our own interface and what is the convention on how to do such. And what is the declaration syntax? How do we make it an interface? And how do we implement an interface? Meaning implementation here is implementing all the abstract method of the interface, because later we're going to see that all method of an interface needs to be public and abstract, unlike in an abstract class where a class is an abstract may or may not have an abstract method. But remember where we said if it has an abstract method, the class itself needs to be declared as such. That is, a class needs to be an abstract class when it has at least one abstract method. But in the case of an interface, all method of an interface must be public and abstract. So we're going to see how the syntax of this and how we can differentiate between an interface and an abstract and when to use each of them, which now I have given an example of in the case of sharing a common type. And another thing, Java does not support multiple inheritance, can only support single inheritance, unlike other languages like a Pascal that support multiple inheritance. Java, it says one child will only going to have one parent. So if we want to enjoy this kind of flexibility, and all remember because of this kind of complexity that's avoided in Java, that we now say, okay, no need of having such multiple inheritance. But if we want to enjoy a similar kind of, then an interface will give you this avenue in order to enjoy the multiple inheritance of a thing. However, it is not multiple. It's just a way to achieve something similar, because that complexity is totally avoided, the fact that we cannot create an instance of an interface. So we see the interfaces and inheritance, and interfaces cannot grow. Yes, because it's just like a building. When you make a very tight building, when you come to make any modification, it's either you destroy the whole thing. So it's the same thing. An interface, once it is built, cannot go and modify. If you modify an interface, it's like you have to destroy the entire building and start all over. Because if you have any method in an interface and if you have any addition or anything added, then that also will lead to modification of all the classes that implement the interface. So this is why when you are using an interface, you have to be very careful in the design. So we then see the difference between abstract classes and interface as well. I hope, guys, you can still see my screen, right?
Yes, sir.
Okay.
Yes, sir, we can see it.
Okay. So now I gave you an overview of what inheritance is all about. We say we have seen the inheritance allow co-reusability. Of course, we know a subclass inherits properties of its own superclass, even though not all properties, but public properties. These are the only properties that can be inherited by a subclass. Now, we said inheritance allow type sharing. Yes, we know it allows type sharing. Why we said a student is a person. A student is a student, a student is a person. So there is a kind of a type sharing there. Yes, there is a kind of type sharing there, because I can say a student is a student and student is a person. So the student is of type student, and also student is of type person because a student is a person. And if you look at employee, employee is a person. And also we can look at a lecturer or a faculty is an employee, and employee is a person. So that kind of sharing type is possible. But what if now they don't have a common things that they can share? This is what I've mentioned that can lead us towards inheritance. So the interface can give us this kind of flexibility. So this advantage of type sharing is what interface is giving us, because they are not from the same class hierarchy. Like I've cited an example with instructor. A student is an instructor, and a lecturer is an instructor. So now they are sharing a type. In this case, now they are sharing a type. So this is the case, because a student cannot be a lecturer cannot be a student. They are sharing a type. So how do we go about it now? We now see what interface can provide. Okay, so now we know the importance of having this interface, apart from this, in terms of type sharing, of course, can give us, and later we see more things that this can provide, like in the case of multiple inheritance. In the case of multiple inheritance. So we said interfaces are used to realize some of the advantages of multiple inheritance, yes, while avoiding its complexity. And this is one of the reasons why Java avoids this complexity, which I have mentioned earlier, that if they say a child belongs to a parent, and this child also belongs to another parent. So this kind of complexity, for you to be able to differentiate, you mean you are referring to a parent of one child, not the other parent. So this kind of complexity is avoided in Java. We know that one child has only one parent. Once we refer to the parents, we know who is the parent of this child. So that complexity is avoided. So if that is avoided, in order to take advantage of the multiple inheritance, what do? We said, okay, even though we have some kind of complexity in that regard, interface provides this advantage that we can enjoy like other similar languages like Pascal. So like in the case of a graduate student, I think I've mentioned this, a graduate student and a faculty. A faculty here is just a nomenclature, means a lecturer. A graduate student who is either a master's student or PhD student, someone who is given admission to study master's or PhD, not an undergraduate, which can be given research assistant to teach. And a faculty is just a nomenclature, means is a lecturer here. So might implement an interface, because we mentioned that a faculty cannot be a graduate student, a graduate cannot be a faculty in this case. There are two different classes. They don't share a common type at all. But something that would bridge between them is the instructor now. The fact that a graduate student can be an instructor and a faculty already we know is an instructor. So this instructor will now be an interface. So how do we define all the possible method of the instructor? But remember, all method of the instructor of all interface must be, anyway, these are the things I'm going to discuss about, must be public and abstract. All the methods must be public and abstract and cannot contain instance variable, like the other one, cannot have a constructor and the rest like. So this is what we're going to discuss now. We said interface sees only declare method and objects that object must have, but with no implementation. That is, all methods are abstract. When we say with no implementation, means all methods are abstract. That means we're going to have a simple something like, let's say abstract, let's say void. We just say read, for instance, abstract, public, abstract, void, let's say read. Something like this, without implementation of anything. We just make it public, abstract, void, read. So it means here, this method read, it has no implementation. And whoever is going to read, if this method is in the interface, then any class that is going to implement the interface must implement the method, how the reading will be done. But as it is here, we know that anybody who is going to be a student, for instance, I may have like an abstract class, let's say student. This is the way to declare an interface. So you now start with interface. Let's say, for instance, student. Interface students. Just the way we declare a class, but instead we're not going to have a class definition. We're not going to have a class keyword here. If you have a class keyword, then it means you are making it a concrete class. And if it is a concrete class and you have one abstract method, that will not make these still to stand as concrete class. It must be an abstract class in that case. So this is, for the case of an abstract class, this is what we write, if you remember, abstract class student. Now I want to make this to be an interface. I want to make this to be an interface. So I need to have a keyword interface. I need to have this as interface student. Now, with one abstract method, public abstract void read. This is the name of the method, abstract method. So any class that is going to implement this interface needs to override this method, must. So meaning whoever is going to be a student must have a method read implemented. Must have this method implemented. Must have the method read implemented that will tell how this will be done. Okay. So now the rules of this, we said, this interface differ from abstract classes. The fact that they cannot have implemented methods, meaning that we cannot have method implemented. But in the case of an abstract class, we can have implemented method or not. What I mean by implemented method, I believe when I say implemented method means a complete method that is not an abstract. That is what you mean by implemented method. So in the case of an abstract class may have or may not have any abstract methods. So when I say abstract method, I mean non-implemented method. But implemented method, of course, is not an abstract method because it's implemented, it's already completed. An abstract method is a method that is not complete. I only say that it's a method read. How to read depends on who is the student. Then you determine how to read on your own. But as it is here, I will not just come and say, read this particular something, or this is how to read. But all I am saying, you must read. So when you are making an interface, this method must be implemented, meaning that whoever is going to implement this interface must implement the method here. So in the case of an abstract class, we said all methods the class may or may not have an abstract method or may not have implemented method. I'm using the two terminologies. So when we said implemented method means non-abstract method. Yes, non-abstract method. Fine. So this is what this is telling us. They cannot have implemented methods. So in the case of interface, no way you cannot have, like, for instance, let's say I have this as read, then I now have this public, let's say, void write. I cannot have this in an interface because once I have this, I have implemented method already. So by just writing this is already implemented. This is already implemented. So this is what cannot be here. The fact that this is an interface. An interface, everything must be public and abstract. Means that all the methods must be public and they must be abstract. But this will cause issue. Now, when you take this and compile it, you're going to have an error on this. Simply because this is an interface and interface cannot have implemented methods. So when I go to the Java Online compiler, let me just take this, have it here. So I believe you can still see my screen, what I'm trying to show, right? So you see here, you see interface abstract method cannot have body. So cannot have body. You see, it's causing issue with the public void write because this is not an abstract method. And this is an interface. So you cannot have that. This is why this is giving us an error. It's saying interface abstract method cannot have body, means cannot have this body. This is the body now. But immediately I remove this and I put semicolon and I come here and add an abstract. this is fine. No error on this because no abstract method. So only that if you are compiling, it says cannot find main method, which is not that error, but it's just a missing main method. And you remember when you come to run a program, you must have a main method. It's just like you are coming in to execute, and the first entry of Java compiler is to find the main method. Once main method is missing, there is no way it can reach out to other part of your program. So when you come to run, you must have one public static void main at least in your code. And also cannot have a constructor. Unlike in an abstract class, we can have a constructor. Remember the one I have demonstrated in last week for abstract class. We had methods, so we had constructor, but an interface cannot have constructor. And remember what constructor is. It means I cannot come here and say public student like this. Remember the constructor must always be the same as the name of your class. And the purpose of the constructor, again, is to initialize instance fields. And we don't have any instance fields in an interface. We cannot have instance variable in an interface. No variable will be created in an interface. So if we don't have any variable, what are we going to have this constructor to do here? Cannot work here. What we can only have is purely an abstract method, like we have demonstrated here. Yes. So abstract method read and write. This is the only thing we can have abstract methods, and the method must be public and probably some constants if we like. Constant means the value that cannot change over time. Like maybe I want to give a bonus. So I will just say public, let's say final int bonus. Something like, so if it is a constant, of course, final, we have to give a value. Let's say I want to give a bonus of 3. So I say final. Final means the value cannot change. The value of bonus cannot change. No one can come and change this bonus to something else. It must be 3. Once it is assigned, cannot be changed. This is why I call it final. When a variable has a final means constant, the value cannot change. When a class has a final means cannot be subclass. That is to say that class cannot have a child class. So when a class is final means it cannot be subclassed. It cannot have a child class. When method is final means cannot be overriding. And one of the things here which I'm going to send in our forum to discuss, can an abstract method be final? That is it. Who can respond? Can an abstract method be final? If yes, why? If no, why? Who can respond? Can an abstract method be final? No response? I hope there are students in the class.
It cannot be final.
Sorry?
It cannot be final. I don't believe it can be final.
Sorry, I can't hear you.
I don't believe it can be final.
So you mean it cannot be final? An abstract
Yes.
method cannot be final?
Yes.
Cannot be
Why?
final.
The first person that's talk, please, can you tell us why?
Because we make it abstract so that later on in the subclasses we can change it, right? And make modifications. So if we make it final, it means like we cannot even make any changes, and it defeats the purpose of making something abstract.
Very good response. You have a bonus of 1 mark. Remind me, what's your name?
Manal Muhammad.
Sorry?
Manal Muhammad.
Okay, so please immediately after the class, you tell me. I'm going to record your bonus as I did for the other one last week. Please, after this class, you let me know. Thank you very
Okay,
much for
thank
this
you.
good response. Of course, the purpose of the abstract class is to be overridden by the child class or by any class going to implement that method. But when you make it final, it means you are saying it cannot be overriding. That contradicts the fact that that class is an abstract method. So we cannot have a final in an abstract method because that would be a contradictory definition there. When you have a method, you said it's an abstract, which is saying any class that is going to implement or is going to override the method that is going to implement, or there is going to be a subclass of that class, or that is going to implement the interface must implement that abstract method. But now you are saying it's final. And when method has a final keyword, it's saying it cannot be overriding. So that's, of course, yes, thank you. So no instance variables except constants. We cannot have instant variable like in the case here now we say a student, and then we now come and begin to write string, let's say string name or something like this. We cannot have this. We cannot. We can only have a constant, which I've given one example here, and abstract methods. All right, so let's move on. So interface names are often adjectives ending in able. This is a convention. It's not something that you must follow, but it's an advice. If you really want to collaborate with others to be a developer, you have to follow standards. There are standard way in which things will be done. So you have to comply with the standard so that when people see when they see something, they know that this is an interface. Because if you just name it the way you want, you confuse others. So an interface is mostly like an adjective. Just like we said a class name always has to be a noun or noun phrase. This is a convention. So, and of course, this is why I always encourage people to name their class with capital letter. Because if I see this small letter S, I know you either have not read Java itself or you don't even understand Java. And that's why you are writing your class name with small letter. Yes. So to have a class with small letter like this, say small s, no. Make it capital S because it's a noun. Or noun phrase. So noun phrase which may contain more than one word, but each word should be capitalized. So you have to make each case capital when you have more than one word. But an attribute of a class will start with small letter and subsequent one should begin with capital letter. And that is why we say that is for that one. Then for methods, the best way to name your method is to make it verb. When you make it verb, then that makes it to be like an action word. And that's why like something like read, write, get, call me, gist me, write exam, something like will be an action word. So this is why, because it's an activity, we call it an activity that will be done by an object. Yes, like we have a withdraw, we sometimes we call it withdraw, or we call it make withdraw, make deposit, make transfer, something like that. Or if you just say withdraw, transfer, if you make it to be like that kind of a verb, I think that is the best way to name. So, and so by seeing that, we know this is a class or this is something. So we said for an interface should be something adjectives like colorable, rotatable, comparable, runnable. Yes. So things that end with able, like comparable, runnable, rotatable, colorable, writable, something like that. And not necessary, if cannot be like an adjective, can be in form of a role, something that can serve as a role to something, like container. The role of container is to hold things. Mover, instructor, these are role. So they don't end with able, but they serve as a role. An instructor is a role. Mover is a role. Container is a role. So things you can as well choose as you want to have. All right, so I think I've I have mentioned this where we said this is an abstract, this is an interface, and you, instead of having a class, you make it an interface. So we say interface are declared similar to classes, except interface is used instead of class. So you make it to be interface rather than having a class. Like instructor here. An instructor is an interface where we expect each instructor to have office hours and teaching courses. So being you as a lecturer or you being as graduate students, you need to implement this interface because you must have office hours and you must have teaching courses. So if as long as you're going to be a faculty, you must have this method implemented. If at all you are a graduate student, you need to have this method implemented. All these two methods you must have them implemented. So either way, you have two options of writing this. Either you write it this way or you write it this way. Writing this way, you must not have the public abstract. But even though you don't have, they are public and abstract, unless you write something. And when you call it private, again, that's also sound contradictory because making a method private when it is going to be assessed by another subclass, would that be possible? Anyway, I should have thrown this for discussion so that someone can get the bonus. But since I have responded, a method, an abstract method cannot be a private method because saying private cannot be assessed outside within which it is declared. And any class that is going to implement this interface needs to implement that abstract method, and you are making it to be private. It means it's not accessible outside the interface. So that's also sound contradictory, similar to that of the final keyword that we said if it is embedded within an abstract method. So all we are saying in summary here, whenever you have an interface, whether you write public abstract or you don't write, it is always public and abstract, like it is here now. So this and this are the same. You can write it this way or you can write it this way. Okay, fine. So if a graduate student, remember, graduate student here, that extends students because it's a subclass of student and implement what? Interface. So if you look at this, who is the child or who is the parent of graduate students? A student, right? It's a student. Now, the fact that a graduate student is a subclass of students, but cannot have two parents, cannot be a subclass of graduate student and also a subclass of instructor. We now have an interface. And what we use for an interface, we use implements, not extend. Extend is for inheritance. Implement is for interface. So when you are implementing an interface, you use implements. So you are saying graduate student implements interface, instructor. So if this graduate student implements this, that means these two abstract methods must be implemented by the subclass. So by that class that is implementing the interface must implement this. Implementation means must complete this get office hours and get teaching courses. Must be implemented. That is, must be completed by that class. If at all, it's going to be a concrete class. If it implements one and one of the method is left, then the class needs to be an abstract. I think I have discussed this when we are discussing on abstract class. So when a class has not implemented all abstract method of an interface, the class itself needs to be an abstract. That subclass needs to be an abstract. The same for interface. If we have a class that has not implemented all the abstract method of the interface, the class needs to be an abstract. That is, in the case of this, get office hours, suppose it's implemented, but this is not implemented, that this is not added here to show the completion of the methods from the interface, then this will make this graduate student to be an abstract class because there is one abstract method from the interface that has not been implemented in this class. Now, I have a question. If a graduate student has not implemented one method of instructor. And we have another subclass of graduate students. Would that subclass of graduate student needs to implement the method of the instructor or not? If yes, why? If no, why? Is the question clear? Can you respond, please?
Can you come again, sir?
Okay. Now, these graduate students implement interface. And if it implements interface instructor, that means all these two methods was implemented, which in this case, they are all being implemented. Fine. So suppose I remove this. If I remove this, that is saying graduate student has not implemented all the methods because there is one that is not implemented. If graduate student has not implemented any methods of the instructor, then the graduate student need to be an abstract class. So if it's an abstract, then it must not implement all the method of the interface, which is okay because itself, the class is abstract. Now, if we're going to create another class that is going to now be a subclass of graduate students, will that subclass of graduate students need to implement the method of the instructor?
Yes, sir.
Why?
That because the graduate student itself is not complete. So the subclass need to implement the instructor so that you can get some of the data of the instructor.
Okay. Okay, so you have tried. What's your name?
So I'm Isaac Orin.
Okay. Isaac?
Yes, sir.
You had a bonus the other time? Are you the one?
Yes, sir.
Okay. So either way, after this, you also remind me immediately after the class. Okay, good. Now, this is obvious and everything is a chain. If this graduate student is an abstract method, the fact that it can have all the methods, even though it has not been implemented, but if it is implementing the instructor and all these methods can be inherited, in this case, let me use the word can be inherited, or will be inherited from the instructor, can be inherited from the instructor, that's because they are public, only that they are abstract, which requires graduate students to implement them, but decides not to implement, then the graduate student needs to be incomplete by indicating itself with a label incomplete. And what will now indicate to have a label incomplete is the abstract keyword. So the graduate student needs to be labeled as abstract because there is a method that is not implemented from the interface instructor. Okay, since it has a label abstract, fine, which can stand as that because not all the method of the interface being implemented. Now, any class that is going to implement, that is going to be a subclass of this graduate student needs to implement the method that has not been implemented by the graduate student, or else even that child needs to be an abstract. So it's a chain. So it means here, we said only when you have done all the activities declared by your parents to do, that you can be complete. Only when you have implement or you have done all the activities defined by your parents that you as a child can be complete. But then you decide to only do one activity and refuse to do the others. Let's say you have two activities, read and write, and your parents say you must read and write, or else you should be incomplete. And you decide to read without writing. Can you be complete? No. So you should label yourself as incomplete. How do you label yourself as incomplete? Add abstracts to yourself. That is why we said, okay, that class needs to be an abstract also. Now, if your child, remember I say your child now, I'm not talking about you because you and your parents, the fact that you have not done all the activities defined by your parents, then your child needs to complete that method writing that you have not completed from your parents. So your child needs to complete that, or else the child also needs to be an abstract. I believe with this example, this is understood. If or else, then you need to rebuild and probably go and sleep and wake up, then you come back. So I think I have discussed about this, and this is where the something here. So don't forget, we don't use a comma here. We just say extend student. That means a graduate student is a subclass of student. But then we cannot say a graduate student is a child of instructor. No, we only say graduate student is an instructor. It's an instructor here. A graduate student is an instructor because an instructor is an interface. So this is the way. And also when we go to get a faculty, we can say a faculty is a subclass of employee and implement instructor, because a faculty is an employee. A graduate student is not an employee. That is why we say they are not from the same class hierarchy. Yes, a graduate student is not an employee. A graduate student is a student. So therefore can be a subclass of student. And faculty is not a subclass of students. But per se, a faculty is a subclass of employee and can now implement instructor. So you see both graduate student and faculty are instructors. So this is where now they are sharing a type. Okay, now we said although method of an interface are automatically public, they must be specified as such in the implementing class. So any class that is going to implement that method must have the public written there, even though in the interface we say they are public. But the implementing class needs to have that public keyword. Must have. So if a class implements more than one interface, we use a comma separator. Yes. So this is the advantage of multiple inheritance now, something like that. You see, why we say faculty extends monthly employee, because a faculty is a monthly employee. Implement instructor means that a faculty is an instructor and a faculty is a comparable, because we can compare two faculties if they are the same. So we use a comparable here. A comparable is an interface from the standard Java library. That is from java.lang package. A comparable, yes. So now, what happens if a subclass does not define all method of an interface it claims to implement? So this is what I asked, and I think I responded to this. I said, what if a class does not define all the method of an interface it claims to implement? Remember, this is why I said the class itself needs to be declared as abstract. So same thing that happens if the abstract method of a superclass is not defined, the implementing class is abstract. So any class that is going to be a subclass of that, or that is going to be the implementing class of that, needs to implement all the abstract. Otherwise, it should be declared as abstract as well. Now, if a superclass implement an interface, then all its subclasses are considered to implement it too. This is the one I have asked other gentleman who has responded. I say, if a subclass implement an interface, okay, fine, whether being an abstract or that is implementing all the abstract method or not, then we said all its subclasses are considered to implement it too. So meaning that if that class, the superclass, has not implemented all the abstract method of the interface, then the subclass will be considered to implement that non-implemented method. I think I've discussed this. Still revolving around interface. Now, in the case of the type sharing we mentioned earlier, yes, we can use a graduate student because we said an interface cannot be instantiated. We cannot have instructor equals to new instructor. We can only have a graduate student instantiated because we know a graduate student is a concrete class. It's a concrete class. Therefore, we can use it to point to an instructor to see that this graduate student is an instructor. So meaning that this graduate student is an instructor, a graduate student is a graduate student is a graduate student is a student, and graduate student is an instructor. The same thing, I can have a faculty here and say it's an instructor. So they are sharing a type here. So this is where now the issue. Graduate student can be of type graduate student, student, object, and instructor. So this is later this is what will lead us to polymorphisms later. As you can see, anywhere you create to say this is a graduate student, that graduate student is of type graduate student, is of type student because a graduate student is a subclass of student, and student is a subclass of object because a student is at the top level, is said not to have any parents, and therefore is a child of object. So meaning that a graduate student is an object by virtue of that. Then a graduate student is an instructor based on interface that we have seen, because a graduate student implements an interface. So it means that a graduate student can be of any of these 4 types. Yes. And then for faculty, implement this, and this and that. Now, one good thing about this, we can create an instance of graduate student and create an instance of faculty. But when we have this print of office hours, we can call this method and pass a reference of faculty or graduate student, because both can accept. Reason being that a faculty is an instructor and graduate student is an instructor. But if I just come here and have probably, let's say, faculty, let's say with an instance faculty here, then only reference of faculty can be passed here. I cannot pass any other thing apart from faculty. But now I have an instructor, and I can pass a reference of faculty, I can pass a reference of graduate student, because both of them are instructors. So another good thing, like classes, interfaces can extend other interfaces. So this is one good thing about interface. You can have many extends keywords. So here, just like we said, we have like classes, interface can extend other interfaces. See, other interfaces. So we have here now container, and container is an interface. We can have this searchable container is an interface, and then use the word extend interface. So it means an interface can extend other interface. But mind you, not to say interface implement interface, but rather in the case of between interfaces, we said interface extends interface. And also, not only one, in this case, an interface can be used to extend many interfaces, which is similar to the multiple we mentioned earlier. So unlike classes, interface can extend any number of other interfaces. Okay, fine, separated by a comma. So here now I can say searchable container, extend container, extend comparable, extend colorable, extend runnable. I can have many interfaces extend by this searchable container. So remember earlier we said container is an interface which is also from the standard Java library, and the role which serves as a role here to store or to hold things. So to hold things, if it is a container, and it's truly a container, all these methods, you can see them are what? Abstract. They are abstract. They are not being implemented because they don't have any body. This is a method, add object, meaning that from the container, we want to use the method add to add any object to the container. So when I say add, I need to have a parameter of objects to add. So meaning that if I have a faculty or anybody, I can use it because I believe a graduate student is an object, faculty is an object, all those are objects. Person, employee, they are all objects, therefore I can pass them here since I'm using a type of the superclass, which all the subclasses are of type its own superclass, which I've mentioned even earlier. So I can use these add methods to add objects to the container. I can get how many objects in the container. I can use this because it's a Boolean method to check whether the container is empty, return true or false. The container is full, which is going to return also true or false. Forge, purge here will now clear the container, remove all the items in the container. So that is the purge. Now we have a searchable container, which also be an extension, an extended of the container. And remember, container is an interface. The fact that this is an interface must not implement all these methods, must not implement, because the searchable container also is incomplete, being the fact that it's an interface. It's not like in the case of a concrete class, when a class implement an interface, needs to implement all the abstract method, or else it should be abstract. So already this is an interface. It's incomplete. So what do you expect it to complete from its own other classes that extend from? So here now we have another method that checks a Boolean object to say, is this a member of this container? Meaning when you are searching, you come with object and say, is this object in the container? Which if it found in the container is going to return true, or else it returns false. Or you want to remove the object from the container, something like that. So I think, so what if have a method declared in two different interfaces, one with the same and same with the exact? We only need to define the method once. Yes. So we are saying that what if we have a method declared in two different interfaces? So it means that we have two interfaces and we have the same method declared in the two interfaces. Do we need to have such? Because we are dealing with interface, why do we need? We only need to have only one method, it suffices. No need of having two methods from two different interfaces. So what if we have method with the same name but with different signatures declared in different interface? Then if we have this method with the same but with different signature, with the same name but with different signatures declared in different interfaces, then each of them should be considered to be implemented appropriately. Because as far as the compiler is concerned, are two different methods entirely, because it is not an overriding method. Therefore, any class that's going to implement that interface needs to implement the two methods separately. What if these methods have the same name, the same signature, but they mean different things? Of course, if they mean different things, that's fine. But there's no way. You need to have them spelled differently. One of them should be different from the other. Yes. So the idea here, when you have the methods have the same name, but they mean different things, so one of them should be renamed, because that will cause conflicts. Like say, for instance, I have add method, the same name, everything the same, but they mean differently. So one of them should be renamed so that there will be no conflict. So we said interface cannot grow. It's important to think that methods and their signatures when designing an interface, because it's just like a building. The building is not well, then, or let me say a foundation. And once there is a problem with the foundation, then the whole building should be destroyed. So this is because interfaces are like foundation to a building. To make changes, the whole building must be destroyed. So you have to be very careful when you are using an interface. This is the risk of interface. An interface is a foundation. And this is why, like I said, if I have a class and I have this class, for instance, here, I say this is, let's say, interface shape. So, and I have public abstract, let's say area, public abstract double area, something like this. And I have another one, let's say perimeter, like this. So, and I have, let's say, something here to say class, let's say circle. So we're now going to use a circle implement or what? we say circle implement shape. So if circle implements shape, needs to override all these abstract methods. Needs to override all these abstract methods. Let me see what, okay, yeah, fine. Okay, so if this cycle implements all this, let's say I have this. I come to implement this. Since this is a cycle, remember we said this must have a public keyword. The implementing class must have this public keyword. Then, so we can have return here. If I have a radius, let me say, assuming I have a radius as, let me just say RR. So meaning in this case here, I have to have, let's say private double R with the assumption that the constructor has been created. I'm just bringing this, so I believe you know what should be there. I must not have a constructor here because this is not the purpose of coming here to explain this particular section. I just want to explain why the foundation, why do we call this shape as a foundation? So the focus is not to write a complete program per se, but some of you will look at it as if you are seeing it for the first time. So let me say radius here, then this dot R equals to R, then end with semicolon. Now, so let me also implement the cycle, the perimeter here. Then here I have return maths 2 pi r. Okay. Maths dot pi times r times r. Then this is 2 asterisk math dot pi times r. This is what the perimeter. Now, so imagine this, we said this cycle implement shape. That means it's going to implement all these abstract methods, these two. And again, I have another method that will now implement this. Let me have another method. Let's say rectangle here. Implement shape, and the rectangle will have double width. Let's say length and the width. So here now rectangle. Then I will make its length double width. So here now come and make it okay. So now here now the formula should be length times width or length times breadth. Something like this. Then here now should be the perimeter should be 2 times into brackets length plus width. Okay, now, so the question here is, if you look at these two classes I have, the circle and rectangle, all implement this interface. I said this is a foundation, and let me show you why it is foundation. If I have these two methods, and this class needs to override all these two methods, that is, need to implement all these two methods, which implemented, and also implemented by this rectangle. Now I come to this and add one abstract method, public abstract, let's say double, or let me say total area. Now, by adding this total area, believe me, adding this total area will make this cycle a rectangle to be broken. They have already broken stuff. Because why they are broken, I need to go and implement this total area in this cycle and rectangle, or else they cannot stand. They need to be abstract, which causes the whole of your program to be reviewed, as if you are now destroying the whole building and start another foundation. Because all these are building on top of this. So when we go back and say we want to go back and modify the foundation, also, how can you modify the foundation and the building that you have or the structure you have on the foundation will not be affected? They must be affected. So in that case, you have to destroy the entire case. And adding anything here is as if you are now destroying the foundation, destroying the building, and start all over. So this is what this is telling us. I believe this is clear now. So how they are similar, I think I've mentioned this. Okay, so this is for you. I think I will get this and share and as an assignment for you to submit next week, latest next week. Now, so what is polymorphisms? I'm going to spend just 5 minutes on this. Polymorphisms, from the word poly, means many. Morphisms means forms. So all we are saying, many ways of, if you like, poly, many forms, ways, many ways of representing object, which I think indirectly I have discussed about these polymorphisms of a thing. How do we represent an object? An object can be represented to itself, can be represented to any type above it in the class hierarchy. So let's go through and see. So already I have talked about these polymorphisms. So this type of references, or let me come here and say, when we call that reference of type, a superclass can be assigned to an object of any of its subclasses. Of any of its subclasses. So for instance, here now, remember when we look at a person, and we said a person is an employee. An employee can be monthly employee, which can be so in this case now, we have an employee as a person, and we have two subclasses, monthly employee and hourly employee. Hourly employee, monthly employee and hourly employee. And under this monthly employee, we have faculty. We have faculty. We have staff. And under this hourly employee, we have maybe another staff, something like that. All this as a category. Now, what we are saying here is When I have a reference of, let's say, for instance, I create an object and say new faculty. New faculty here. I'm creating an object of faculty. Now, anybody who is a faculty, as you can see here as a class, that faculty is a monthly employee because a faculty is a subclass of monthly employee. Therefore, I can use this to point to this. I can say a faculty is a faculty, okay? I can say a faculty. So let me say something fac here. And I can say a faculty. I can say a faculty is monthly employee. I can say a faculty is an employee. And I can say a faculty is a person. Tell me, is there anything wrong with this? Anybody who is a faculty, meaning that anybody who is a lecturer is a lecturer. Anybody who is a lecturer is monthly employee, means whose salary is paid at the end of the month. Anybody who is a faculty, that's a lecturer, is an employee. And anybody who is a faculty, that is anybody who is a lecturer, is a person. So meaning I can use this to assign to any of these: faculty, monthly, hourly, sorry, faculty, monthly, employee, or person. So I can use any of this type. I can use it. Any of this type I can use. Now, the fact that I can represent this in this number of ways, this is what we call polymorphisms. Polymorphisms. Yes. Polymorphisms. And this is what this is telling us. For example, we recall that a reference of type superclass can be assigned to an object of any of its subclasses. Yes. This is a superclass. There is a class itself, monthly employee, the subclass. This is a superclass. Use a reference here. Use this one on this. So similarly, a reference of type given interface can be assigned. So not only the concrete, even that one that we mentioned. Remember, we can even add instructor here. Remember that an faculty implement instructor. Therefore, I can also add an instructor here. So you see how I can represent this in many ways. So I can represent this in this number of ways. So this is what you mean by polymorphisms. Because a faculty is a faculty, of course. A faculty is monthly employee. A faculty is an employee. A faculty is a person, and faculty is an instructor. So like that. So these types of reference are therefore called polymorphisms or polymorphic references, since they can take different forms. Different forms means they can be represented in this. They can take this in this form. This can be represented in this form. This is polymorphisms. I believe this is clear. So the same thing when we have a square and a rectangle here. A square can be represented as a square. A square can be represented as rectangle, and rectangle can be represented as shape. So this is an example of polymorphisms where can allow us now to combine multiple without any segregation: rectangle, square, and circle, which I think I've demonstrated earlier when, was it last week? Or last 2 weeks. So I think with this now, question, I can happily, okay, let me talk about, I think I've discussed about off-down casting the other time. Yes, changing the type. Changing the type. Now, if this is a faculty, I'm changing the type here, and I'm from faculty type to an employee type. This is called upcasting. This is called offcasting because when I have a reference of faculty, I have an object of faculty, reference an employee, then this is called upcasting. But when I take it down to a faculty, so this is why it says if we keep switching off and on from this now, because as far as this is concerned, employee here is a member of employee. Imp here is of type employee. But when we come here and assign this imp to a faculty, then this will cause an error simply because this imp is not of type faculty, is of type employee. Because right now we have upcasted these objects to be of type superclass. So assigning this reference to a faculty will lead to an error because the type must match, the left and right must match. So this is of type faculty and this is of type employee. There is mismatch there. We downcast it by wrapping this in brackets to change this imp to a faculty. So this is okay. This is called downcasting, and this is what we call narrowing conversion. So the same thing when we create a vector, I believe you did this in COSC212. A vector is a like dynamic array. And you know, array in Java has limitation. When prior to assignment, you need to tell how many elements you want that array to hold. So if you have it as a vector, vector can grow. Vector can grow, you can add as many objects as possible in the vector. But when we have a vector as this, and we call this add method to add every shelf to the vector, then when we come here, we want to now call the method in order to print all the details of, or to string method of that class. The fact that each of these now, the rectangle, square, circle, are all of type vector shelf, are all of type vector. Therefore, this needs to be, their type needs to be changed to shape for them to work. Otherwise, by the time you say shape.getI, I'm sorry, this will cause trouble because you have to then cast it to shape. All right, so, or we use instance of methods if you want to separate or to check whether something is an object of a shape, like in the case of getting the radius, because not every shape has a radius. So if we now say circle.getRadius, this will cause trouble, will cause an error. What do? We need to cast this to a circle because there is no getRadius in the shape class. And shape class is an abstract, is an interface. So we cannot have getRadius there, and we cannot use the type there to call the getRadius method. The getRadius method is a method of the cycle. So this needs to be done cast to cycle before you now call this getRadius, and this is what this one does. Yes, question? I think with this now I can start packages so that next week you read about JVM. When you read about JVM on our next class, anyway, let me hear from you. We still have 15 minutes. I think this package of it shouldn't take us time, and I'm sure you have been seeing this package for quite a number of times when you are using Eclipse. When you use Eclipse, you will see this package. Yes, question? Any question from the?
Yes, sir. Question, sir. Good evening, sir. Once again.
Okay.
Sir, my
Yes.
question is I want to know when to use. I'm taking you back to interface, sir. I want to know when to use implement and when not to use it. When to use extend.
When to use an interface or when not to use? Is that? You want to know when to use an interface, right? Please, can you unmute your speaker and speak?
Sir, can you hear me now?
Yes, I can hear you.
I said I want to know when to use extend to access the superclass in an interface and when to use implement to access the superclass, because I observe that you can use the both of them. So I want to know when to use it that it will not cause conflict. Thank you, sir.
Okay. So, and the only thing here, if you want to enjoy polymorphisms, you can just put it in any way you want to put it. But all we are saying, when you have an interface, you can pass a reference. Like remember here, let's say I want to say print details. Let me see if I understand your question. Let's say here I have a method print details. Let's say void print details. So here now I have instructor. Let's say instructor. Okay, now if I have this instructor, let me say static void print details. So somewhere I now call this print details. So I now have, let's say here I have a faculty. So whatever the constructor, remember that I'm just assuming that we have a constructor here called faculty with whatever we pass as a parameter to the faculty. So when I come here, I want to call this print details. And the print details is this. And the print details require to have instructor as a parameter. So which reference will I pass? Must it be an instructor or can be a faculty? So all we are saying, I can pass a faculty here because a faculty is an instructor. That is one. But in the situation whereby in the instructor here, I don't have this, I only have a faculty. So sorry, before then, let me finish this first. Then, or I have something like this. I can also refer this to like this and have instructor. Then I can pass this pack here. So I can either say this pack is of type faculty or this pack is of type instructor. Either of these I can pass it here. Because a faculty is an instructor based on the interface. Faculty implements interface. So I can pass a reference of type instructor. I can pass a reference of type faculty if I have an instructor here. But if I have a faculty in here, it means only object of faculty I can pass. I cannot even pass a student. In fact, I can even come here and create a graduate student and use instructor here, or use an instance of or an object reference to that. So I can say ST, for instance, equals to new graduate students. So I can pass ST here. All because we have these print details that accept one object of type instructor. The reason graduate student is an instructor. So if a graduate student is an instructor, I can pass this with print details to print for graduate student. I can use it to print for faculty. And either way, I can pass this also as this. I can still pass ST here. So it's either I pass reference of type faculty, reference of type instructor, reference of type graduate student. Either way, because a graduate student also is an instructor. But if I come here and make this one to be faculty, this is restrictive. I can only pass a faculty, regardless of the name here. Don't be deceived by the name. What matters is the type. What I have here is just something named. I can still leave it as instructor, but it does not mean I can pass a reference of type instructor. What matters is the type here. Okay, so if I have it here now, leave it as instructor, which is of type faculty. what I can only pass here is this faculty. I cannot pass instructor. I cannot pass instructor, and I cannot pass graduate student. I cannot, because I'm making it to be restrictive. But if I have an instructor, I can pass faculty, I can pass instructor, I can pass graduate student, because a graduate student is an instructor that way. Yes, Isaac, did I respond to your question, or I didn't get your question correct?
So I didn't get my question. So I was talking about an interface, not a polymorphism.
Yes, in an interface. What is the question in the interface?
Yes, I say when to use extend and when to use implement to access superclass.
Okay, is that your question?
Yes, sir.
Okay.
You, sir.
Now, if you have a class, let's say concrete class. I mean concrete class, any class. So in this case, if I'm going to implement, let's say, anyway, let me have public interface shape. Let me have public abstract double area. Let's say these abstract methods. So I now have here public class. So if I'm going to say this class cycle is going to now make use of this interface. If it's using interface, I need to use implement keyword. If this is a cycle and this, which is a concrete class, and this is an interface, I need to use the keyword implement, then implement what shape. So in the case of interface, I use implement. Now, if there is any class that this cycle going to be a subclass of that, then I have to use what extend. So it means I can have extend and implement all in the same class. All depends on. So, but in this case now, I'm only interested to say cycle implement shape. Therefore, is cycle implement shape, like we said, must implement this, which is obvious. Now the concern is when to use implement or extend. In this case, if a class is going to make use of the interface, you use implement keyword. But if this is an abstract class, class, then what we use here, we use extends. We use extend keyword in this case. If this is an abstract class, we use extend. We don't use implement. We use implement only when we have interface. We use extend only when we have either abstract class or even concrete class, must not be an abstract, either way. This is the normal inheritance, we use extend keyword. But in the case of abstract, we use implements. And what we said, if we have an interface and suppose this interface going to now, let's say, suppose this cycle going to implement another interface. So we can now say interface like this. Then in this case now, if interface can extend other interfaces, so you now use extends. In the case of interface, so when interface going to now make use of other interfaces, you use extend, not implement, because it is an interface already. So you use extend. So this can extend many, let's say comparable, comma, runnable, because not only one, comma, just like, but in the case of concrete class cannot have many subclasses, but interface, fine, can extend from many interfaces. So comparable, runnable, comparator or container or whatever, Yes, something like this. Yes, is that clear? Did I respond correctly? Is that your question?
Yes, sir.
Okay, fine.
Yes, sir.
Okay. So I think this is clear now, the use of the extends or implements. For extends, we use it when we want to extend either interface or other concrete classes. And implement, we use it when a class going to implement an interface. So implement used for interface, extend used for concrete class or abstract class. Simple. Where in the case of an interface, we can use it to extend many interfaces. But remember, all these are interfaces. They are not concrete classes. If they are concrete classes, it means you are saying chef is a child of many parents, which is not the case in Java. But you can still use extends if all these are interfaces. Yes. Yes, more question, please. So according to our time, we have just 2 minutes. And let me see if I can finish this package in 2 minutes or in addition to 2-3 minutes. What is a package? We have seen package in most of this IDE, like in Eclipse here, when you create a program. When you create a program here, you will see a package and look at the package here. This package definition with this keyword. So this is our topic for today, which in this case, what this package means. Package here is just the way we organize our files, just like the way we have a directory where we organize files and keep them based on their similarities or based on their relevancy. You have my document, you have my pictures, you have within even my pictures, you have some kind of organization. Let's say you have your family picture, your friends picture, you have school pictures, all organized in their respective folders. This kind of organization will make it easy for maintenance. Make it easy when you want to look for any picture, you can refer to it, or any document you want, you can always refer to, because your files are well structured, well organized. The same thing, when we are writing program in Java, we organize them based on package. So we put them in the package based on kind of similarity. Anything that has to do with student management system, we put them in their student management. If there is going to be any cross interaction between management and hospital, we create a hospital management and have all classes and interfaces related to hospital management, despite the fact that there will be a kind of cross communication between students and the hospital. So in this case, we have student management as a separate package, and we have a hospital as a separate package. So this is why now, remember when we talk about access modifiers, so some of the access modifier, we see how they work by looking at this package of a thing. So in the simple term here, just the way we organize files in our system, computer system, the same thing we organize our Java classes in a package like that. And this is why when you look at this package definition, which is always be the very top here to have it. And here now we can see we have this added here. We have the package, and you can see a folder is created. When you run the program, compile successfully, this will be created. These students here refers to the package. So when I have this as a different package, another folder with this name will be created, and this class, when I compile this, that compiled class will be stored in the package that I have specified here, saying that they are not of the same package. So if I want to develop an application, for instance, one for hospital, one for student, despite the fact that there will be a communication, then anything related to hospital should be in the hospital package. Anything student should be in that student package. Not only that, to enjoy this kind of organization for easy maintenance and flexibility, but also to have to avoid conflict between two classes that probably exist in two different packages. because I may have a student, for instance. Now, let me take an example of university. We have, let's say, a class called students in the university, and let's say in ABU, and we have another student class in BUK. So how do we resolve these conflicts? Even though there are standard rules that says we use a reverse domain name, that is part of the naming convention. I think, okay, now let me go over to this as quick as possible. And these are some of the packages we have seen earlier, which like java.io, when you are writing program that has to do with anything input output. Later, we're going to make use of java.awt for abstract Windows toolkit, or Java applet when you want to write an application that will work on the browser, even though it's somehow obsolete to use the Java applet. Now we have Java FX that is more robustic. So these are some of the packages, just like you want a kind of a tools that you want to import in order to develop an application. So this is why we say all these Java classes and whatever are organized, the Java API are organized into packages. So some of these that we have enjoyed, like the use of, remember when we make use of java.util.scanner, that scanner is a class in util package. So we import it in order to make some of the classes and interfaces in util package available within our program. We have to have that import statement. So this is the importance of having that import. You are importing the API for you to make use of. So some of it, like avoid conflict with class name in other packages when we have it in a different package. Like for instance, you have a package, let's say ABU, and you have a package BUK. So within this, you have a student. Now, if I have a student in this package and I have student in this package, how can I differentiate? Which class am I calling? Is this class student of ABU or class student of BUK that I'm referring to? So this package of a team will now allow us to use a fully qualified name by saying abu.students. I mean, I'm calling this of student class. So this is why in our import statement, if suppose now, let me just consider abu.edu.ng, which says, if you want to do this, you write them in the reverse order, ng.abu.edu.abu. This is the convention in which we organize, we say we should write. So it means if you want to create a class with abu package, you now have this on the very top, have this package ng.edu.abu, meaning that what you are going to now create, if I am going to have a class here now, I will say public class student. So when I run this, when I compile this program and run it, so you just compile. When I compile this program, a file or folder will be created. The folder will be ng, and inside the ng folder, I'm going to see another folder, edu. Inside the edu folder, I'm going to see abu. So inside the abu, I will see student.class when I compile my program. I will see the student.class. So if now I want to do the same for BUK, so I now come here and say this is now BUK, or for any other university, for instance. So I will now say here, when I compile this program, again, inside the ng, all these they are going to have a common root directory, which is ng.edu, ng.edu. Inside, I will see abu here with the students, BUK with their students. So there will be no conflict, even though this is implemented specifically for abu. This is implemented specifically for BUK. So this will allow us now, let's say, for instance, NUC to harmonize all these classes so that if there is any API that one wants to make use of, and that API is related to only ABU, which probably from the student class, then the student class can be imported specifically for ABU. Or you are interested in making use of some of the properties or methods of the student from BUK, then you can now specifically import for BUK by using the fully qualified name of the package, so that we know that we are calling student of BUK, not student of ABU. So in the case where we are to make use of any of that, then all I need is just to come here and say import ng. If I'm going to make use of the student from a specific university, then I will say ng.edu.abu.student. So meaning I'm importing student class of ABU, not student class of BUK. So I'll know that there will be no any conflict, because if I just say import students, from where? Is it from ABU or from BUK? So this is the case now. All right, so, and then you can now begin to write whatever you want to write. You write your own class, but all this you are using an API created, which is stored in this. So you now write whatever and then enjoy all the methods that are defined in this, if you are allowed to use them here in your program. This is why we have the import statement. Okay, so I think in order not to take much time, we stop here. By next week, I'm going to reverse this and show some examples on how to run program using a package and using command line, not just necessarily using Eclipse. On Eclipse, you can specify all this, the package name and everything, and that's also created automatically. And you can have many classes with their own respective kind of package. And then we can now try some of the access modifiers like public, private, protected, and default to see to the extent in which we can access things. We only discuss about private and public. As mentioned, like default will be there. So only when we discuss this package that we can now understand what all the public access modifiers needs. So let me ask if there is any question, please feel free. If no, then we can stop here. Next week, we now do more on packages, but I'm going to give a reading assignment for you guys. Read about Java Virtual Machine. Our next class, I'm not going to talk about this Java Virtual Machine. I will read it for you for reading assignments to read. Just discussing about how internally a program is represented in the computer, the way it is interpreted by the Java Virtual Machine, JVM. Java Virtual Machine. So the way methods are being stored or objects and the rest like, and how it is being interpreted and everything. So you just read about JVM architecture, please. And until that's, so in our next class, when we come, we revise in packages and then go back and talk, and then we continue with nested classes. Yes. So by the time we do this, by next week, nested classes, upper week, we'll do GUI. Yes. So question? Yes. Any question, guys? Okay, so in the absence of no question, I think we can stop here.